All right, I'm on page 15 in your exponentials packet to give you some more examples with the characteristic of exponentials. So I'm going to kind of jump around and do a few examples here and then let you move on and practice. Let's look at this first one. Okay. I want to remind you that 2 to the x is a parent function. That is not a transformation. Not. But instead, it tells us where we're starting from. So this is my parent function. So if I actually plot those points like you should when you graph, you can then use the transformations to help you graph. So that's a +3, so that's left 3. So I'm going to go 1, 2, 3. I'm going to go 1, 2, 3. And I'm going to go 1, 2, 3. So I'm going to get really close to my asymptote. Notice I draw my asymptote first, and I'm going to curl this thing up. Okay. I can get those same values from my calculator to graph. So I would type 2 raised to the x plus 3, second table, and I have -2, 2, I have -1, 4, 0, 8 on my graph. Okay. Everything we talk about, we're talking about from the transformed graph. So you can use your calculator to create those points. So what is my domain? My domain will always be -infinity to +infinity. My range is from the bottom of our graph to the top. Well, the bottom flattens out at our asymptote, which is y equals 0. And at the top, this arrow is pointing towards positive y values, so infinity. Is this graph increasing or decreasing? Does it have a positive or a negative slope? It has a positive one. All right. I'm just going to graph this transformed function because notice each of these parent functions in 1, 2, and 3 are the same. So you know where you're starting from. So I'm going to use my calculator. I'm going to say y equals, I'm going to delete that, +3. Second table. Notice as I get to y values of 3, click the button. I'm never getting past 3. It's getting almost to 3. There it is. But I'm never going to pass it. That's telling me in my calculator, that's telling me in my calculator that that's my asymptote. I also know it's my asymptote because that's what's being added out back. So I'm going to draw my asymptote at 3. And I'm going to scroll back in my table to find points I can actually plot. So well, I think my calculator has officially bit the dust. So let's use a different calculator. Second edit function, clear it out, 2 raised to the x, arrow down, +3. All right, so looking for points I can actually graph. I can actually graph 0, 4. I can actually graph 1, 5. I can graph 2, 7, and then I'm off my graph. So again, I'm going to get really, really close to my asymptote, and I'm going to curve it up. My domain is always -infinity to +infinity. My range starts at the bottom and works its way to the top. So bottom, there's my asymptote. I'm not crossing 3. Top, this arrow's pointing towards positive infinity. We just said our asymptote is at 3. And is this function increasing or decreasing? It is certainly increasing. Let's work on one more example. Let's work on number 5. Looking at my parent function, that's my parent, and my base is less than 1, so that's a decay. Again, that is not a transformation. It is not. It's not a transformation. It's just letting me know what my graph is going to look like. I can identify my transformations. This is telling me that I'm going to the positive, so that's left. This is going up. Well, if it's going up 2, that's my asymptote. Okay. So let's use our calculator to find this function. So I'm going to say 1 divided by 3, and I'm putting inside parentheses, raised to the x plus 1, and then plus 2. I had an arrow down. Again, we're looking for points that we can plot. So all of these positive numbers become fractions. So I'm going to move towards my negative numbers. So 3/11's off my graph, but I can plot -2, 5. I can plot -1, 3. And then I get another fraction. So my asymptote is here. I'm getting really close to it, and then I'm curving it. That's what a decay function looks like. That means this is decreasing. Okay. My domain is still negative infinity to positive infinity. My range, I'm still starting at the bottom and working my way to the top. Well, at the bottom of our graph, we get to our asymptote. And at the top of our graph, that arrow is still pointing towards positive infinity. Finish the rest of these examples as practice and check your answers on the block. You're going to submit questions 3 and 4 on page 18. On page 3 and 4, on questions 3 and 4, page 17 and 18, ignore maximum, ignore minimum, ignore positive, ignore negative. You don't have to answer those characteristics, but you're going to answer the rest of them. Happy practicing, and let me know what I can do to help.